Hey Patriots, in this video we are going to talk about arc length, what arc length is and how to find it using a formula. Before we find arc length though, I want to talk about circumference, because circumference and arc length are related. Remember, circumference is the distance around a circle. It's the perimeter. So we can calculate circumference two ways. We can say circumference is diameter times pi, or we can say circumference is 2 times pi times the radius. So circumference in both cases is the distance around the circle. Well, I'm going to use the formula whichever I know. So diameter would be this distance and radius is going to be this distance. So in this first circle, my circumference, we are going to use diameter pi because they give me diameter. So the circumference of this circle is 18 pi. However, in the second circle, they didn't give us diameter, they gave us radius. So I'm going to use the second equation right here because this equation has radius in it. So circumference equals 2 times pi times 18. And 2 times 18, because we're going to keep pi as pi, 2 times 18 gives me 36 pi. So that's how we find circumference. Why do we care? Why do we care what circumference is? Well, that's because, oops, I forgot to highlight that, circumference. Arc length is related to circumference because arc length is a portion of my circle's circumference. Basically, if you take a piece of the circumference and you cut it off with tin snips and you hammer it flat, this distance right here, this length from the edge of the circumference, from here to here, this is what we call arc length. Arc length is just a piece of the circumference. And we have a formula that helps us find arc length, because arc length is directly related to the number of degrees a circle the arc length covers on my circle. So we have a formula. We can use it one of two ways. I personally like the second way the best, but either way works. So arc length is this piece right there. It's that length. Arc length equals, oops, let's highlight it right there too. Arc length, there we go, is 2 pi times the radius. Remember, 2 pi times radius is circumference. This number right here, 2 pi times radius, circumference, 2 pi times r is the circumference. And then we're going to need the degrees that are in that arc divided by 360 in both cases, because every circle has 360 degrees in it. So basically arc length is the portion of the circle we cover in degrees, but we have to multiply that by the circumference. So let's find the length of arc AB. We're going to round our answer to the nearest hundredth, 2 decimal places. Alrighty. I like the second formula the best. I like the second formula the best. I like the one that says the length, arc length, compare that to the total circumference. The piece of the circle over the whole circle equals degrees from the circle over the whole circle. Basically what I'm saying is I am saying part over whole equals part over whole in both cases. So arc length, L, is this distance right there. That's what we're going to find. To find arc length, we're going to do 2 pi r. There's r. In this case, it's 8. Equals degrees in the circle. Now remember, that's a central angle. Central angles are equal to the degrees of the arc. So when I plug it all in, we are going to say arc length, that's what I'm looking for, over 2 times pi times r. 2 times pi times 8 equals 60 over 360. Boom. And we are going to go ahead and we're going to solve this equation for my variable, which is L. We're going to get L by itself. So to get L by itself, we need to cross multiply. L times 360, that's going to give me 360 L equals, now I'm going to go ahead and I'm going to do this multiplying. 2 times pi times 8 is 16. So I'm going to do 16 times 60. Actually, it's 16 pi times 60. Oh, my alarm is going off. It's reminding me to do something. So 360L. You know what? I'm going to be clever here. Let's go ahead. And I'm going to divide both sides by 360 so I get the L by itself. I know what you're thinking. Mr. Gilbertson, why didn't you go ahead and multiply those? I'm going to show you why here in a moment. I could have said 16 times 60. I have no idea what 16 times 60 is, though, so I'm not going to. These 360s are going to cross out, leaving me with an L. And what's going to happen right here is this is actually, I'm going to reduce this. So 60 goes into 360 6 times. Then I'm like, wait a minute, the 16 and the 6 reduce. I can divide both of those by 2, and that's going to give me 8 pi on top and 3 on the bottom. So the length of that arc is 8 over 3 pi. Boom. That doesn't look like much of an 8 right there, does it? That looks less like an 8. A little better. Boom. I'm going to show you a different way that we could have done this one. So let's find the length of arc XY. Instead of calling it arc length, I might say, hey, find the length of the arc. We're going to round our answer to the nearest hundredth if needed. Oops, that's what I did not do on this one. I left it as a fraction. I forgot to round it. I know that's what you were thinking. You were going, hey, Mr. Gilbertson, didn't we need to round that? Yes, we did. And when I round it, I find that this arc length is 2.6. You know, I made a mistake. You know what I didn't do? I didn't multiply it by pi. So don't forget to multiply it by pi. And when you multiply it by pi, use the pi key. We have to use the pi key to get stuff into Canvas, because if you use 3.14, it's not quite right. So this is going to become 8.38. Boom. Use my calculator. Use the pi key, and that's how long that arc is. Let's find the length of arc XY, which is, again, arc length. Round our answer to the nearest hundredth, which is 2 decimal places. So I'm going to do part over whole. Arc length over the entire circumference equals part over whole. The degrees from the arc equals the degrees of the whole circle. So my arc length right there, that's what I'm looking for. I need the radius, which is 9 inches, and we need the degrees right there, which is 90 degrees up here. 90, boom. So arc length, again, I am looking for arc length, so I'm going to call it L. That's going to go over 2 times pi times r. So 2 times pi times 9 equals my degrees, 90 over 360. Now I'm going to show you a little bit of a shortcut that I'm going to knock out here. So my arc length over 18 pi, because the entire circumference of this circle is 18 pi, and I only want a part of that, that's going to cover how much of the circle? Well, 90 over 360 is 1/4. What this is saying is my arc length covers 1/4 of the circle. That's what we're saying. Let's find out how much 1/4 of the circle is. So we're going to cross multiply. So 4L equals 18 pi. Divide both sides by 4. Divide by 4. Divide by 4. The exact value for my answer is going to be 9 over 2 pi. Unfortunately, Canvas won't let us enter that. So we are going to have to say what that decimal equivalent is. And in this case, it's 14.14. And that is about 14.14. All right, let's do one more. I want you, we're not going to do one more. I take that back. I thought we were, but we ain't. So what questions do you still have for your teacher? So when you come in tomorrow, we're going to be talking about this on our bell work. So make sure that you can find arc length. You understand that it is a portion of the circumference, and that portion of the circumference that it covers is the degrees in the arc divided by 360, part over whole, part over whole. That's how we are going to solve this. So if you have any questions, please let us know. And Patriots, we will see you when we see you.